So we're going to discuss a few things today. We're going to discuss a lot about what has gone into the Android operating system in the last couple of releases. And the agenda of this presentation is that we want to take a look at some of the features that have gone into the OS, specifically features that have to do with dynamic theming on the Pixel devices we've seen. And I don't know why it's jumping ahead, but let's try to, OK, so we want to take a look at the dynamic theming features into the Android operating system and how they work under the hood. So the code name for this project is Monet, and there's a way of looking at Monet is that it's the dynamic theme engine, but perhaps it's a lot more, and that's what we intend to understand here, how these features work together. So we will take a look at various parts of material design. We'll take a look at some of the color science, and we'll take a look at parts of the operating system that enable some of this. So a little bit about me. Here's a picture of me with some of my friends. My name is Sid Patil. I am an Android engineer here in Berlin. I work at Delivery Hero, and we have a booth outside. So if you'd like to check us out, do drop by and say hello. So before coming to Berlin, I was working at a company called Paytm. So Paytm is a mobile payments platform in India. I helped build some of the software there with payments. It's about 100 million users or so monthly actives. So great stuff at Paytm. And I also help organize a couple of communities like Android Worldwide and Kotlin Mumbai. So if you are into attending more events like this, do check out some of our communities, which is the Android Worldwide and Kotlin Mumbai. We have an event coming up on 26 July, I think. So that's a little bit about me. And if you'd like to connect with me, I think you will find relevant links on my website, siddharth.com. Do drop by and say hello, and I'd like to connect with you all and discuss some of the ideas that we are understanding in this presentation today. Cool. So let me start with a couple of questions, and perhaps we do a raise of hand here. How many of you have seen this logo before? Cool. So again, OK, not a lot of folks. So this is the material logo. This is a new material design logo. So anywhere you see this, this is material design. And how many of you use a Google Pixel here? A show of hands. Oh, a lot of Team Pixel folks here. So perhaps a lot of what we are going to discuss would interest you in terms of OS. And have you heard about this thing called Monet before? Like, have you heard, again, show of hands? Oh, OK, OK. I think not a lot of folks again, but this will be interesting because we are going to talk specifically about what Monet is within the operating system. And how many of you use this design guideline, which is Material 3 in your application? Show of hands. Have you played with Material 3 before? OK, OK. It's a great design guideline, by the way, and we have some folks from Material here, so perhaps they want to have a talk with you and understand. It's relatively new with M3 components for Compose, that really work out of the box to build your application. So definitely check out the Material Design Guideline. And let's see Material U here, right? There's no announcement, but let's take a look at it. OK, oops. This is the Android Jelly Bean user interface. This is exactly 10 years ago. So we're in 2022. And don't worry, this is no episode of Dark on Netflix. We are not back in time. But perhaps what I want to do here is just to take a moment and understand how the operating system user interface looked 10 years ago, and perhaps also understand how some of the new changes have come to make this possible with Monet. So this is the Jelly Bean release. And let's see the current real face of the Android operating system, which is Material U. So if you see, there is a lot that has gone into making this, the clean aesthetics of it all, the muted color tones. And the way this feature works with dynamic theming is that when you set a user wallpaper, it picks up the most prominent colors from the user wallpaper, and then it propagates those colors to the system UI, to various packages within the Android system, and also third-party apps that run on the device. So you see things here with the dynamic themed icons and so forth, so on. So this is Material U. So what is Monet? And if you have to broadly classify what constitutes as Monet into the operating system. So I understand it's an OS feature. It's a new feature into the system UI. But it's a lot more than just a feature. There's a lot of theory, science, work from the material team that has gone into making this possible. So if you have to simply understand this, it's the dynamic theme engine on Android. That's the best way to put it. OK? And it enables features like dynamic theme color and themed icons, especially on Android 13. I think the API now is offering us this feature to use monochrome, drawable, and you can just use color palettes from Monet to paint the theme icon. So if you have an icon and want to support this feature, it's now available. And it was first introduced with Google Pixel devices starting in Android 12. But we saw the fuller parts of Monet, the rest of the packages, actually get added into AOSP in Android 12L. So that was the release. Now let's think like system developers here, perhaps. Maybe take a moment to understand if we engineers here want to build this feature out, how would we build it, right? We build apps, we build good apps. So now let's talk about how we could build some of the system features and take a moment to think and brainstorm. So I think the first step of this logic is to read and understand changes in the wallpaper, right? Because this entire logic builds with the wallpaper at the center of it. So the first part of the logic that we're going to discuss is how to observe changes in the wallpaper from the Android framework. The second piece of this logic is to make sense of information from the wallpaper. So a given image could be easily made up of multiple pixels, millions of pixels, multiple colors. So how do you make sense of this information is the next portion of the logic that we will discuss. And how do we extract the most dominant colors from the wallpaper, right? Because we want the most prominent colors. Easily, there could be so many colors in a given image. How do you understand that an image is made up of which color is the most prominent? So this is the part where the material design team has done some great work with color theory here, and we will see some portion of that. So how to extract the dominant colors. And then we want to map them to a specification, right? Because you can easily extract, maybe perhaps run some algorithms and extract a color, but to make meaning of it and build a design system around it, that takes some work. So how do you map them to a design specification is what we want to understand. And we will see material 3 in action here. And then we will also see how we want to dynamically, at runtime, propagate each of this logic into various apps, starting from the system packages and the third-party apps, right? How do you refresh the context with the new colors? So we'll see some of that. So let's step into the framework. We'll see various portions of this logic. We'll see parts of AOSP. And I've tried my best to structure this presentation in a way that we see only relevant portions. There's a ton of code there, and it's completely impossible to cover given the length of the presentation. So the components that we are briefly going to understand are within the system UI are the theme overlay controller, the theme overlay applier. We are going to see the system UI package that is Monet, the new package that got added, and the utilities in this class within the Monet components. And we will see the wallpaper manager and wallpaper manager service, which are core to the framework and how they work with different things. So we will see the wallpaper manager service. We will see portions of the graphics, palette API, the palette class. We'll see wallpaper colors, and we will understand at a lower level how quantizers work, right? We want to understand some quantization logic. How do we run the image through quantizers and extract meaningful information from this? So that's what we're going to discuss today. So let's take a look at wallpaper manager service. So the wallpaper manager service is it's a system service, a core part of the framework, and the portion of this logic that I want to highlight is the wallpaper observer. So this is the first part of our logic to understand changes in the wallpaper, right? So we see a wallpaper observer, which is extending a file observer. And it's really simple. It's not too complicated system code. So what we are doing here is we are identifying a difference with the current image in the system environment for a given user and checking if the new file has changed, like if it's the same file, if it's the new file. And that's how we understand that the wallpaper has changed. So now there's two things that can happen here. There could be a change in the system plus the lock screen wallpaper, or home screen plus the lock screen wallpaper, or we could just have a lock screen wallpaper change. So that's why we are observing some of these changes on both the wallpapers. And another part of this is once we understand that the wallpaper has changed, we want to propagate this and extract colors from it, right? So this is the wallpaper part of it. We also run into a logic called per display connector. So if you have like a multiple display scenario, it builds connection with the wallpaper service, and it will run through each of the connections and understand these changes and notify that the wallpaper colors have changed. So now let's get into the Monet package of the system UI. The first place where we see relevance of this is a feature flag. and we developers love feature flags. We like to test, A/B test things, and do experiments. So the first place we will see this is flags and feature flags of the system UI. And here we see is Monet enabled, which is a static flag. So it's an OS feature flag. A given OEM can decide to enable or disable it and build Android with Monet enabled or not. We also see usage of this flag in the theme overlay controller of the system UI. The theme overlay controller contains a colored listener. So now there is the wallpaper manager and wallpaper manager service working together to understand changes in the wallpaper, extract colors, and the system UI needs to listen to these changes. So we see one of the listeners here, which is the on-color change listener, and post interception of an event on colors change, we trigger logic to handle the wallpaper colors. Okay, so the wallpaper manager service. Now let's take a look at what we need to do here. We need to validate that the system needs to extract colors from the wallpaper, the current state of the system, and then we need to proceed with extraction logic from the wallpaper. So we'll take a look at how the color extraction logic works, and then we have the notification logic. It will notify, the wallpaper manager service will notify every observer that, hey, the colors have changed. So how do we go about the business of understanding how to dissect an image and make meaningful information from it and understand colors? We decode the image into bitmap and then pass this bitmap to extract wallpaper colors from this wallpaper colors utility from the core framework package. And now we will step into understanding a bit about how to extract colors from the wallpaper. So let's get into color extraction logic of it all. The first place where we'll see this is within the wallpaper colors class. So before we proceed to extraction of colors, we need to optimize the size of the image, right? We cannot just go about and a given wallpaper could be made up of different aspect ratios, and it could, we have to optimize the wallpaper color extraction area. So we see this hard-coded constant for identifying a given area. We crop and create a scaled bitmap of this. Then we pass this calculated bitmap to the wallpaper colors, where it will calculate and extract colors from the image. So the way this works is we have the palette API, and we are using quantization here. Don't worry, we'll understand what quantization is for a given image. So we are using the palette API and running some logic on it through the quantizer to extract colors. But there's something interesting happening here. We see two portions of the logic. There is a check called is-low-RAM device. So the Android system may use different quantizers if the given system resources are less. Like for example here, if the RAM is less, right? And this is determined at build time when the system image is built. So current understanding is if you have a device with less than 1 GB of RAM, then that's a low RAM device. So we see a different older quantizer being used here and a limit on the maximum colors that will be extracted. So let's look at how we want to identify dominant colors using a quantizer, right? And this is the portion where we step into a bit of theory here and understand how the teams that have involved on this, how they built this. So image quantization, I think we can take a look at images as a set of information points, right? So a given image could be made up of multiple sets of pixels, right? And each of these pixels are information points. Here's a picture of President Obama with a quantizer run on it. And thanks to Princeton.edu for some of this experiment. So it's really minimal, by the way. But the thing that I'm getting at here is that we necessarily don't want to process each pixel in an image. We want to reduce the number of pixels so that we can optimally calculate the most effective colors, right? So the way this works is we run through a quantization algorithm. A quantization algorithm reduces the number of pixels on the image and effectively reduces them so that you can calculate colors from it. And yes, of course, each pixel is of a given color. A lot of pixel talk here, team pixel. But yeah, each pixel consists of a given color. And Android uses k-means for clustering. Once we have reduced through quantization, we want to also now group some of these colors together. So we will use various grouping algorithms. Here we are using k-means, which is a method to group certain portions of information set. So we see variational and Celebi quantizers. So these are techniques to map the various colors and group them together. So these are some of the algorithms. And depending on OK, I don't know what's happening here, but let's run through this quick. Yeah, given the device RAM, we will see different logics being used, different effectiveness of this color extraction algorithm. So let's step into color science here, and I think this is the portion from the material team that has gone to make this possible, some color science here. So a given color is from a spectrum of light. Two of the most common color spaces are the RGB and the CMYK color space, just for an example. And each color space is used for a different purpose. It's more suitable. For example, CMYK is more suitable for print. And there is an HSL model also. Think of this as ways to understand a given color, right? HSL here stands for hue, saturation, and limit. So hue, saturation, and lightness of a color, and these are ways to understand how a given color is represented. But what we see is that the Android uses the HCT model. So the HCT model, they came up with a custom color model to more effectively calculate colors. So they built a color model out of current strategies that are available, and they built this custom HCT model to build logic for calculating the colors. Let's take a look at Material Design's HCT model, right? It stands for hue, chroma, and tone, okay? And it's a blend of two color models, HCS and CAM16 color spaces. So it uses two different color spaces and combines them, blends them to make more meaningful, more effective representation of color for material hue, okay? So it's the best of both color systems, and here is some of this in action, like a HTC color space where you are mapping tone of different shades. So the way we do this is LCH is good at representing the lightness of a color or darkness of a color, but the CAM16 color space is more suitable for playing around with the chroma and the chroma of the color and the saturation. So we play around with these values and use appropriate, most effective techniques from different color spaces. And here is a representation of HCT versus some of the color spaces. So if you see, the RGB model here represents maybe red and green more effectively, but the HCT model has much more, much more representation of color. So that's how it works. And where does this become relevant for us, right? It solves better contrast ratios and understanding accessibility issues. So they found out that playing around with the tone of the color actually helps in building some of the accessibility related things in building the theme so that they can better calculate A11Ys there. And like I said, Android uses this custom HCT model to calculate colors via Monet. So why Monet, okay? As a name, just why Monet? Why call this feature a Monet? So I think here, Monet is a French painter, by the way, and here is this image called Impression Sunrise, a painting from the painter. And we see this image being passed through the quantization algorithm. So if you pass this through an older algorithm, we see that not a lot of colors are retained, but post processing of this image through quantization, we see much more color retention using the Celebi quantizer, using some of the HCT color models that the material team has come up with. And this is where they perhaps thought to name this project entire feature as Monet. And a lot of this stuff that I'm speaking about is from the material design blog. It's by a person named James O'Leary. Big shout out to this person. And if you want to read more about the color science of it all in finer details, do take a look at his blog post on material design. Now let's think about type systems here. How would you represent a color just as a colored, typed out object model? A palette is made up of swatches, right? So we see there are lists of swatches, and a given palette may have a dominant swatch. We are playing around with the most dominant color here, right? So we have the dominant swatch, and a swatch is easily just a color, right? It's a way to say, a way to represent a given color. And it also has this value called population count. So what is this population count? It is the number of pixels represented within an image that is the population count. So the more the population count is, the more chance of it becoming the most prominent color of the theme. Okay? So how do you find a seed color? So the entire premise of Monet builds around identifying the most dominant color and then processing this color to a given specification. So how do you first get to the point of identifying the seed color, right? So we see some sorting and ranking logic here in place. So the swatches that are extracted through the post-quantization are sorted by the population count that we just saw. Beyond this, what we want to do is we want to assign a score to a given color, right? So we want to identify which colors we want to use in the theme and which colors we do not want to use in the theme, right? So there could be some darker tones or lighter tones that perhaps are not more suitable to play around with. So we assign a score, and there's a custom scoring logic within the framework. The colors are then sorted, and by the descending order of the score, the higher the score, the higher the chance of it becoming the most prominent color, the seed color, so to speak. We iterate through the scored colors to find the difference in the hue, and if you find two nearest neighbors in this sorted list which are close to each other by a given threshold, that becomes a seed color, and then we proceed with calculation of the material theming system through Monet. Cool. So now we have identified the seed color, and now we'll see how to reevaluate the system theme. We want to dynamically calculate some of the changes in the system, and we want to see how the Android framework propagates some of these changes from the system UI to other parts of the operating system, starting with the system packages, and then also third-party applications and Material 3 as well. How does it consume the color? So when would you reevaluate the system theme? Okay, if I have to just take a moment here and understand this. The first boot of the device, that's where we will see this. So when the device first boots, we see some system theme reevaluation, some color calculation happening there. If we receive an intent via the action wallpaper has changed. So if we saw there's a wallpaper manager and wallpaper manager service, and if we receive this intent that the wallpaper has changed, we have some logic within the system UI to process these changes. On a new user setup, right? You could create a new user on your Android device, and each user will have a different wallpaper. So perhaps there is where we would also need reevaluation of the system theme. And then if you change the active user, if you switch the user, then perhaps we also want to reevaluate the system theme. So how does this work? One example here is the system UI, the theme overlay controller of the system UI accepting color events when we receive the new intent. So runtime updates of colors, how do you propagate the changes? We see something called a get overlay function within the theme overlay controller. The way this works is it calls the class called color scheme. It builds a new color scheme. This is the package. This is the class from Monet, from system UI. It builds a color scheme. It takes into account the system dark mode or light mode, and it builds a color scheme out of this. And this is where I think we will see the actual usage of what we will use as Android developers if we were to access system resources. So what is happening here is the colors, the color shades that we just saw Monet calculate, we rank them with the luminosity index, and we identify what is the palette index of it. So you create the system resource IDs, and this is how it would look. Just an example of it. We calculate colors and resource IDs. This is where we would actually get access to some of the colors that the Android framework has calculated. And how does this work to propagate the colors to different packages? We have a utility called theme overlay applier, and this applier will run through various packages within, not sure what happened here. Just a moment. Yeah, OK, we're good. So yeah, it will run through the theme, the various categories. These are packages. So there are packages that are shipped with the framework, with the system image. So it will run through priorities of where it wants to repaint some of the parts of the operating system, which packages first need to be notified about it. And then, of course, the third-party applications, the ones that we build, how they will receive runtime updates. So let's see how that works with Material 3 and Compose. OK? So we see a class from the Material 3 for Compose called tonal palette. And tonal palette is made up of, this is the material specification. We see a primary color, we see a secondary color, and a tertiary color. And we also see a neutral color and neutral Q variant. Visual representation of this is from material.io. This is how you would actually visualize some of the colors that have been extracted, post mapping from the seed color and Monet generating the palette, the color shades. We identify different tonalities of the color to identify 13 shades of a given color. So there is this dynamic tonal palette class, the dynamic tonal palette function, which returns a tonal palette, and it is accessing these exact resources that we just saw the Android framework build, the system resources for the color, resource IDs from the context. So the way it's accessing this is through this utility color resource helper. It's just taking them from the context and then utilizing them to build out a color scheme. And this is where we as app developers will consume some of the APIs for the color, to build a color scheme and play around with dynamic colors. So here we see a light color scheme being built with the tokens that were generated. So if you have to play around with this, I think the best way of summarizing a large part of what we just discussed today, I know it's a lot to absorb, given the nature of the project, various parts that have gone to make this possible. The best way to visualize this logic is coming from the Material Foundation project on GitHub and the Material Color Utilities project. If you want good colors, quantize an image, reduce your information set from the image, and then assign a score, identify which colors you want to actually use, assign a score, and then build a scheme from it. Build a scheme just the way the material design is building a scheme from it with primary, tertiary colors. Build a scheme from it, and have tonal palettes, right? We play around with tone, which is SCD color system. We play with tone to build different tones of the color, of a given color, 13 tones, and there is this SCD color model. So if you want to tinker with this at a much lower level, you can use the SCD color model to understand how it's using chroma and different values to build this system out. So this is a great picturesque representation from the material team, I feel like, and I thought it would be appropriate to place it here. And that's where we arrive at Material U, new face of the Android operating system, the new feature we've seen in the last couple of releases. And I think a lot has gone into making this possible. So I want to give a couple of shout-outs here. A big shout-out to the Android team, the Material team here, who have built this system out. And James O'Leary, do check out some of his work. So if you want to understand the precise color science that has gone with the HCD color system, definitely check out some of the work from James. And material.io for various sources. Guru Singh, who is here, Gurupreet Singh, he is the material DevRel. So if you have any questions for Material 3 and using Material 3 in your applications, do definitely reach out to him. And a large utility that helped me was the Android code search. So you can right now also take a look at some of the code within the source using Android code search and view files from the framework, and check these out. So to further read about this, I think there's the post that I wrote, which was chasing Monet inside the Android framework. And I think, received some response on it. So here we are with a talk about it, a larger conversation. So it explains much more of the logic, a lot more files and finer details, so you can understand this. So do read. And thank you, Dankishon, for attending this session. I really didn't know how I was going to follow up manual stock with a room full of people, but I hope I did a good job in presenting some of the ideas here that have gone into making this OS feature possible. So thanks a lot for attending this session.